Hello everyone, myself Divya and I am a maths educator. I have been in the teaching profession from last 12 years and I have experience of teaching both Indian and UK curriculum, that is your CBSE board and IGCSE board. Today we are going to learn how we can apply the knowledge of trigonometric ratios in the real world problems. So let's start it. Moving on to the application of trigonometry, let us first have a quick review what we all know about trigonometric ratios and the word trigonometry. Trigonometry, I am sure everyone must be aware that has been derived from three Greek words tri, gon and metron. Tri means three, gon means sides and metron means your measure. So basically trigonometry makes the use of ratio of the sides of the right angle triangle. It is also useful in your field of astronomy, your physical and engineering sciences and your navigation and many more. So let's now have a quick review of what we all know about trigonometric ratios. I am assuming that you are all aware. We are going to learn how we can apply them in the real world problems. Trigonometric ratios, as we discussed, that it is associated with the sides of a right angle triangle. So when we talk about right angle triangle, we have some special names in association with the trigonometric ratios. Suppose we have this right angle triangle. This is a right angle and we already know that the side opposite to it is known as your hypotenuse. Now suppose we name this triangle as ABC and we are talking about this angle C. So in relation to this angle C, and before defining trigonometric ratios, we have some special names for these sides. The side which is touching this angle is and the other side which is touching this angle is hypotenuse. The other side is known as your adjacent side. And the side which is opposite to this angle, which is not touching this angle, is known as opposite sides. Using this nomenclature, we define the trigonometric ratios as first ratio is sine of angle C. In short, it is written as sine of C. It is defined as your opposite ratio of opposite upon hypotenuse. Similarly, the other ratio is cosine ratio, cosine of angle C, which is in short written as cos of C. It is defined as your adjacent upon hypotenuse. And the third ratio is your tangent of C, which is in short written as tan of angle C, and it is defined as your opposite upon adjacent. So these are the three ratios. In UK curriculum, if you see that you can see that there is a short form to learn these ratios, that is your so ka toa. Basically, what does it mean? S is for your sine. Sine means opposite upon hypotenuse, cosine means adjacent upon hypotenuse, and TOA is your opposite upon adjacent. So this is one acronym which you can learn to remember these ratios, that is sine, cosine and tangent. Now let's move on to the application of these trigonometric ratios in the real world. So we have this problem. An aeroplane receives a signal from a point X on the ground. If the angle of depression of the point X from the aeroplane is 30 degrees, we have to find the height at which the plane is flying. To solve such type of problem, first what we need to understand, we have to find out whether this plane is making any kind of a right angle triangle with the base. Yes, we can see that this is your making a right angle triangle. This height is exactly same as this height, so this is making a right angle triangle and we can apply the trigonometric ratios here. Second thing what we have seen that this aeroplane is making angle of depression with the point x. Now what is angle of depression in elevation? I am sure all of you must be aware. Angle of depression when your line of sight is below the horizontal level, and angle of elevation when your line of sight is above the horizontal level. So here, because aeroplane is making the angle with the point x, so the line of sight is below this horizontal level, and this is called the angle of depression. Now this line is parallel to this line, and these are making a pair of alternate angles, so we get this angle is also 30 degrees. So what we have got, that this is a right angle triangle in which we have this angle is right angle, this is 6, and this angle is 30 degrees. This is 6 kilometers. So we have to find this h. So we have to see which trigonometric ratios involves these two sides, which is the opposite and the hypotenuse, that is your sine ratio, sine of angle 30, which is your h upon 6. It means h is equal to, we can write sine like this also, and this is 6 multiplied by, you can write in the short form also, sine 30 degree. This you should all must have learned the basic values of sine, cosine and tangent ratio. Sine 30 degree, 60 degree, 90 degree, 45 degree, 0 degree. Sine 30 degree is half. Therefore, h is your 3 kilometers. The plane is flying at the height of 3 kilometers. So I am sure everyone must have understood the concept and must have enjoyed this session. Hope to see you again. Thank you.